Welcome to Building 9, the space vehicle mock-up facility here at Johnson Space Center. And as you mentioned, the home of this year's RATS Research and Technology Studies test. Going on this year, we're having an asteroid simulation, and that involves several different elements, but one of them is this multi-mission space exploration vehicle, which actually has 2 astronauts or crew members at a time living in it for about 3 days at a time and switching off throughout the 10-day study. All this to see what it's like to explore an asteroid and see what technologies we're going to need for that in the future. And one of them, of course, is the powering of the SEV, the rover that we're using. And here to tell us about that, we have Abby Ryan, who is the lead engineer on the fuel cell that we're using to power it this year. Thanks for joining us, Abby.
Yeah, no problem, Brandy.
Okay, well, we're going to walk this way. This is the space exploration vehicle that we're powering. And then over here, we have the fuel cell itself that Abby's going to tell us about. So, what is a fuel cell?
A fuel cell is a power source that we've used in space ever since Gemini, on Apollo, on Space Shuttle, and we're hoping for future missions. What it does is it takes hydrogen and oxygen and essentially smushes them together in a big box, and out you get power and water. There's obviously a lot of chemistry involved in that, but that's the basic idea. So it's great for space because we get things that we actually want to use, aka power and water, that's safe for the crew to drink. You can use it in vehicle cooling, and you can make your food with it in the galley.
Okay, so in this case, they're using it to power the displays inside the rover, that sort of thing?
Everything that's running in the MMSCV right now, all the displays, and also their air conditioning, which we obviously don't really have in space, but very important here in Houston, Texas. We're powering that as well. We're also powering ourselves, so there's absolutely no wall power being used in this demo while the fuel cell is running. So it's definitely more of a space-like configuration.
Okay, and so why is it important to go ahead and start looking at how this would work, how it would fit in with other systems?
Well, it's definitely important for us. We're testing out a lot of new technology for fuel cells. Obviously, the Space Shuttle was our last big fuel cell program, and that technology is about 40 years old by this point. So we've got a lot of new technology in here, regulators that were designed here at NASA, so we're getting a lot of good data on that. It's also important for the MMSEV team to be able to run off of a space power source. We can do things like plot their power usage over the 4 or 5 hours that we're running and give them good data on what type of power source they're going to need, how much power they're using on a daily basis to run all their operations, stuff that wall power just won't tell you.
So if they want to read at night, how much is that light costing?
Exactly. Every time they turn on a light, we can see a blip. Anytime they're powering an engine up, even though it's all simulated, we're still trying to simulate that power, so we can give them that data.
Okay. Well, and then you also said that it creates, when you put the hydrogen and oxygen together, H2O, water, and that gets us into kind of the in-situ resource utilization.
Definitely.
One of the things we're going to want to do in the future is bring as many, or use as many resources from what we're exploring as we can. So tell us a little bit about that.
Yeah, absolutely. Well, the fuel cell, like I said, yeah, it creates water. That's its only byproduct. So a lot like an engine creates exhaust, a fuel cell creates steam and water. And the water, like I said, it's fully potable. The crew could drink it. But you could also use that water with an electrolyzer system. And what an electrolyzer does is essentially the opposite of a fuel cell. So it takes water in and splits it back into the 2 gases, hydrogen and oxygen. So it takes power in and puts gas out. We take gas in, put power and water out. So you could kind of come up with a system where now these can work together so that you're constantly creating power and water and gases. You could add in, based on where you're going, either systems that take water from the ground. We've, for instance, found there's a lot more water on the moon than we thought there was. We think the same with Mars, and we don't know yet about an asteroid. But we think that we can actually take water from the dirt that we find in the ground by heating it up and extracting the water that way. You can also find hydrogen in Martian atmosphere. It's a methane atmosphere, so you can break apart that methane, use that hydrogen in the fuel cell. So it's all about what you said, in situ resource utilization, finding what you can get that's helpful to us out of the product that's already there, which is atmosphere and dirt.
Right.
We have a lot of that, so how can we get things that we want out of that?
Especially as we start going further out into the solar system or further distant planets, we're not going to want to bring this stuff with us because it's heavy, basically.
Right, and even a cargo mission, to get to Mars, it takes about 8 months. So if you want water now, you need to figure out how to make it where you are.
Right. Okay. Well, how is the test going so far?
So far, it's been going great. This is our 3rd day running with the MMSCV, and we've done about 4.5-hour runs each time. Basically, we're limited by the amount of reactant we can put in these tanks. And they're kind of small, but it's what we had in the lab. So far everything's been great. We've been able to run all of their power for the days. We've gotten some great graphs, and I just really couldn't be asking for it to go better. So I'm very excited.
Well, and all this was built by NASA?
Yeah, here at JSC. All of the material inside is fuel cells that we built here in our lab. It's the Propulsion and Power Division, and we work on this in the Energy Systems Test Area here at JSC. The housing that it's in was built by Langley out in Virginia. It's called the PUP, or the Portable Utility Pallet, and it's basically part of the MMSCV architecture. It's detachable from the MMSCV, so you could leave it at the Deep Space Hab and just put in it maybe what you want. So if you're going on a week-long mission and you want power and water, maybe you take the fuel cell with you. Mm-hmm. Or if you're going somewhere else just for a day or two, maybe you want something else to bring with you instead, extra tools or whatever. So the idea is that you can kind of detach what you want or don't want. So Langley is working on that project, and they built this whole housing for us. So we were kind of constrained by that and ended up building the system up from there.
And I think you were telling me you think you can actually get it a little smaller, right?
Definitely. We're working on a newer technology. Like I said, it's always, we're definitely always pushing for lighter, meaner, faster, all of those things. And with fuel cells, the biggest change that we can make is getting rid of what we call the balance of plant, or the BOP. And that's all of these tubes and pumps that you see right here. We think that we can make that system a lot smaller. One of the ways that we're working on doing that is by getting rid of all of our water management. Right now, the way that the fuel cell gets water to come out of this tube right here is just by shoving extra gas through the fuel cell to move it through. Mm-hmm. And then you need pumps to kind of pump it through the system to get it out. So what we're working on is what we would call a non-flow-through fuel cell, meaning that we aren't flowing through the gases to move the water. Instead, what we would be doing would be wicking the water out of each cell, kind of like water off of a duck's back, where it just wants to go that way. So that's what we're working on. What that would do is just get rid of 2 of the pumps that we have in this system. It would get rid of 3 different tanks. So we're working on just getting rid of all the ancillary components and making it a smaller system.
Great. And I guess, smaller is better probably for here on Earth too, or the ways we could use it here?
Absolutely. Right now, this is kind of an intimidating system to stick in your car or in your house. But if we can make this smaller, then maybe folks will want to actually start really looking at fuel cell cars as an option. People are, I think, starting to get on board with hybrid and electric cars. And I think fuel cell cars are the next step. There's already a few companies, Honda and Toyota, make fuel cell cars. It's great because here on Earth you don't need the oxygen tank. The air has enough oxygen to run a fuel cell. And so all you would need is hydrogen with you. It's a gas that kind of scares people, but I think they get Hindenburg images in mind. But it's definitely safe if you handle it correctly. And it's one of those things that when you educate people and kind of introduce a new technology to them and show them all the ways it can benefit, I think that it can really take off. Like I said, the only exhaust from our system is steam, and so that's a lot better for the environment if we can start working on that.
Speaking of the steam, also you can get water straight from the tap here, right?
Yeah, absolutely. Right. This is our fill plate right down here. It makes it easy to be able to fill up our tanks. There's a hydrogen port and an oxygen port, and that spout down below empties our water tank inside. So you could stick a cup underneath there, open up the spout, and drink the water if you wanted.
We don't have a cup with us, but you've tried it, and it's safe and perfectly drinkable.
Yeah, I one time kept about 3 Gatorade bottles of fuel cell water and had a fish living in a fish tank with fuel cell water for a few days. So it didn't die. It's fine. So yeah, it's fully drinkable. It's actually, in order for the human body to really use it the way that we are used to using water, we actually have to add biocides to it. It's too clean for our bodies to deal with. So that's kind of an interesting fact.
All right. So we should have lots of uses for that in the future.
I hope so.
Thanks so much for talking with us. Again, this is Abby Ryan, the lead engineer on the fuel cell.